Welcome back. Today I have prepared a tiny little program which is just a loop, and moves the string to the left, and then we look at how conditional traps are set up, and as a dessert I have prepared to show you the beauty of the EDMK or ED instruction. So let's have a look at the program. No, we don't need that. Here we have the program, and we change the font to a normal size. Okay. Now the program, it's almost identical to the program I used in the demo for loops. It sets up the bass. And it uses a technique which is good so that the register for addressing the definitions covers also the code, but that is not the main thing. The main thing is that you have an easy calculation when you look at the offset in your program. You can easily calculate from what you see there where the code is. Now, and the loop. What we do is we set up a work area with this is a test string that will slowly move off, and it will move that to the left, and always one character to the left until the blank is hit, and it will end the operation when two blanks in a sequence come, which is the case here at the very end of that literal. And then we edit the message, and and what we'll do is we will stop the looping at let's stop it when the word count reaches 2. Okay, now first we compile that program, stop, and I have set up GCL for it, which is here, and we submit that as well. Now go to a 30 to 70 screen, which is here, and here's the compile, which went to 0, and here's already the start of the execution, and go right into the middle of it, trap batch, and we have that indicates source support is here. So now we can single step, and we'll move that over, and we can go into that loop. Okay, it does it multiple times. Now we would like to stop it when the loop counter for words reaches 2, 3, 4. Let's say we want to stop it with 4. Okay, and we have the location, which is 30.8. Now put that down. I have not coded the conditional trapping in source support because I have a strong belief that to use source support, to use the conditional trapping facility, you have to have a certain understanding of the code, and you need to understand that when you look at it. You can, so without thinking too much about it. So the instruction we would like to stop on is at on the next screen. It's at 102, which is this here. Okay, and we will tell it stop at cursor PF2. Oh, cursor's not there. Now it's there. PF2, and the comparison is 30.A. Compare against hex value of 004 dog and we would like to have it a length of 2, and we would like to have it equal. Now it accepts that, and we press PF2, and we have the trap set on the right location. Now when we press PF10, it will stop there, and we can check that register 3, 1, 2, 3. Oh, we can actually check that in here. We can check that by going with PF5 there and PF5, and we have 004 dog in the field, and the work field here will slowly move off, so parts of it is already moved off the screen. Okay, so far to conditional trapping. Remember, you do that, you can have an absolute address, a relative and displacement address, or a register, and you can compare that against an absolute address, relative and register value, or a register value, or an immediate value, and that immediate value can of course be either character or hex length, and the result tested is equal, greater, lower. Overflow, not equal, not greater, not lower, not once. But I do not support test under mask instructions, so I don't know how to create an overflow. Anyway, so in one nice thing I would like to show, which is this. Here we have a regular memory display. Here we have plain translation into ASCII. Now, if you would like to look at stuff which is in ASCII, usually you have a hard time doing that on an IBM machine, because they only support ASCII. So what you can do, you can either look at the hex and learn that by heart, or you can use PF6, which is not right now, but we can switch to the alternate meaning, and then we have PF6, which shows some data in ASCII just for this demo. Okay, and we let it end. Oh, come on. Okay, so now look at that result string. Moved the string 47 times and found 9 words. Now, the dessert, how was that done? Look at the program. The program has just one et, but there are 2 numbers. Now the authors of the 360 instructions, which were, I don't know how many, maybe 100, maybe 120. However, the original instructions were pretty neat, and edit was a tricky instruction, and some say it's unnecessary. I say it's nice if you know what you can all do with it. Now what I do with it here is I have 2 counters, which is the move counter and the word counter, and I count them in negative. Negative because the mask, the edit mask, which I use in this instruction, consists of this mask and of this. I mean, everyone knows the 204 digit selector, but the almost forgotten thing is the 21 is pretty well known as the start digit selector, which forces, if a field is all 0, it forces the just 1 0. So instead of having this, and I know that I will always have a number of a value greater than 0, so it's not necessary, but you could also code this, and that means start writing the digits, Now why did I use this? This is separator, and what happens is when it comes to editing a negative number, both numbers are negative, it here it selects the first, it takes the first character and puts that in place of the zeros until it finds that start significant digit, and then it edits it. Now, the minus tells it stop suppressing digits. So at that point, when it edits, it switches back on, showing whatever is there. So we will see that times and found. And then we have the selector field, the separator field, which is, we have a new field now. Whatever you have, forget about it. We want zero suppression. So it takes that, suppresses this, and brings in the replacement character, which is a blank. Brings in replacement character, significance, and a zero. But we always have a number, so it doesn't really matter if we have 2 zeros or 2 ones. But this is vital. If that would be a blank, it would suppress all these and not show any numbers. Try it for yourself if you don't believe me. That concludes it. Thank you for watching.